Compute the double integral over R, region R, of the function x dA, where A is the area element of the region R, and the region is bounded by the parabola y equals x squared minus 4x, and the line y equals 2x. So let's see if we can make a sketch of this region. Y equals x squared minus 4x, a parabola that opens up, and if we write this as x times x minus 4, we can see that the roots are at 0 and 4, setting that equal to 0. So we have a parabola with roots at 0 and 4, and that means the vertex is in the middle at 2, and if we plug in 2 here, we get 4 minus 8, which is negative 4. So down here we have negative 4. This is the vertex. So we have a parabola that looks something like this. And this is our parabola y equals x squared minus 4x. And then we have the line y equals 2x, which also goes through the origin. And it's got a slope of 2. And so this is our region here. This point is the point where do they intersect? We have to figure that out. So that's where the y coordinates here are equal. So x squared minus 4x is equal to 2x, which means x squared minus 6x is equal to 0. And then we can see that x is 0. We already knew that one. And 6. So this one has an x coordinate of 6. So plugging 6 into either equation will give us the point. Here is 6 comma 12. This one's a little bit easier. So this is the point 6, 12. And this is the point x is 2 and y is negative 4. This is 4, 0 and 0, 0. Now normally we write this integral in both orders, integral of x dy dx and double integral, iterated integral of x dx dy. And in the dy dx case, that means that we are filling the region with vertical slices, and vertical slices are very nice in this region. They go from the parabola at the bottom to the line at the top. But if we look at this region the other way, here's a rough sketch of the region. Dx dy, then we're looking at horizontal slices in the region, and that's not a good picture. That's not making the point. Let's make a better picture. The line didn't go through the vertex. It goes through some point on the side here. There it is. And there's the line. Now, dx dy, we're filling this region with horizontal line segments. And horizontal line segments, they go from the line to the parabola. If you're above this particular line here, they go from the line to the parabola. But if you're below that blue horizontal line, they go from the left half of the parabola to the right half of the parabola, which would require us to rewrite this equation in terms of x and get a left half and a right half. Now that can be done by just thinking of this as a quadratic equation, x squared minus 4x minus y is equal to 0, and solving for x, we'll get two, quote, solutions. One of them would give us a formula for the parabola in the left half, and the other would give us a formula for the parabola, the right half of the parabola. But that's a bit of work, and if we don't have to compute both integrals, then we will simply at this point choose the first one, because these vertical slices are very nice. And so let's proceed with that. Dy dx. So this is a double integral of x dy dx. We've chosen this order. That's an important part of this problem. One order is much more convenient than the other. And the x values go from 0 to 6. And the y values go from the parabola to the line. So from x squared minus 4x to 2x at the top. So the dy dx integral was easy to set up, and the dx dy integral, we would have to separate it into two integrals, and that second one for the bottom half here, we would have to solve this equation. And we get some pretty gnarly looking things. We've all seen the quadratic formula and the complicated expressions that come out of that. So none of that if we integrate dy dx. Okay, so now computing this integral, we're integrating with respect to y first. So x is just a constant, and the antiderivative is x times y. And we have to integrate from 0 to 6, and here we have to plug in the line at the top for y and the parabola at the bottom. And then when we're done, we have to integrate dx. So integral 0 to 6, plug in 2x for y, and that gives us 2x times x squared, and then minus, and we have x times, and we have to plug in the parabola, x squared minus 4x. So we have to integrate all that with respect to x. So we have 2x squared, and then we have minus an x cubed, and we have plus 4x squared. So altogether we'll have 6x squared, and then we'll have minus x cubed. So simplifying this again, 2x squared plus 4x squared makes 6x squared, and minus x cubed dx. And now we just have an elementary integral in the variable x. Antiderivative, let's finish it out. X cubed over 3, so that gives us 2x cubed because of the 6, minus x to the 4th over 4 from 0 to 6. So we have 2 times 6 cubed minus 6 to the 4th over 4. And I'm going to do a little bit of fancy arithmetic here. I'm going to write the 6 to the 4th as 6 cubed times 6, and then I can factor out 6 cubed, and I'm left with 2 minus 6 quarters, and 6 quarters is 3 halves, so that's a half. So the answer is a half of 6 cubed. 6 cubed is 216. Half of 216 is 108. Okay.